Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 10, Lesson 8, Other Types of Regression, Common Core Algebra Number 1. In the last two lessons, we fit bivariate data sets with lines of best fit. One of the keys I want you to remember there is that we're talking about the lines of best fit. So today we're going to talk about exponential graphs and quadratic graphs, because not all examples are linear models, and they are not the best choice. We can fit data with all sorts of curves. Like I said, we can talk about the linear curve, the exponential, or quadratic. But these are many other types. Before we look at exponential and quadratic regression, recall the general shapes of these two types of functions. So don't forget, my exponential kind of looks like a J in both directions. My quadratic looks like a U in both directions. So today, by the time you're done with this video, you should be able to decipher between a linear, exponential, and quadratic lines of best fit. You will also be able to use your calculator to identify the exponential regression of the equation. Let's go ahead and go through exercise number 1. For each scatter plot shown below, determine if it's a best fit line of a linear, exponential, or quadratic function. Draw a curve of best fit depending on your choice. So A, you should be able to see that there's a little curve going on here, so that should be exponential. B, talk about my curve, and it should look like that, and that's my quadratic. My C is a decay of exponential. My D is straightforward linear. E is another linear, which has a positive correlation. And my F should be my quadratic. Should be easy enough to decipher between the exponential, the quadratic, exponential, and linear functions in these examples. We're going to go through a couple other examples where you're not going to be able to tell unless you graph it and identify your R value, which we're going to learn tomorrow. But we want to make sure that you can decipher, and if they tell you how to get to my exponential. Our calculators can produce equations of exponential best fit and a quadratic of best fit, along with a lot of other types of curves. Exercise number 2. Biologists are modeling the number of flu cases as it spreads around the particular city. The total number of cases, Y, was recorded each day. X after the total first reached 16. The data for the first week is shown in the table below. Use your calculator to find the exponential regression. On the left and on the bottom are the exact steps that you would use in your new calculator to go ahead and identify, by using your calculator, the exponential regression. The first step that you want to do is type in your data, making sure that you remember to identify both columns as X and Y. Then you're going to hit Menu, which is Statistics, Stat Calculations, so all we're doing is following our slides right down. Then we're going to go all the way down to right here where it says A, Exponential Regression. Once we hit exponential regression, make sure you type in your X and your Y, because those are the two different sets of data. And slide number 5 is going to show you what it's going to pop up on your calculator. Noticing that my formula Y equals A times B raised to the X power is right here. It tells me my formula. It tells me right here what my A is. So if I want to round everything to the nearest hundredth, I'm going to say 15.92. So I'm going to write Y equals 15.92 times, what is my B? 1.12 raised to the X power. And I get these answers right here, and all I have to do is put them in the proper place in my formula. B, based on the regression equation, how many total cases of flu will there be after 2 weeks? Well, we should know that 2 weeks is 14 days, so all we have to do is type in 15.92 times 1.12 raised to the 14th power. You could also type in this equation into my calculator, leaving my X. You can type in that original and go to my table and go to get 14, and gives you your answer as well. C. According to your model, by what percent are the flu cases increasing on a daily basis? When we look for that information, don't forget we're pulling it right from there. It's 1.12, which shows a 12% increase. 12% increase. Once again, for question number D, you should type in this into your calculator and go ahead and find the answer. It says hospital officials will declare an emergency when the total number of cases exceeds 200. On what day will they need to declare this an emergency? So we're going to type in that information, and we're going to go ahead right in there and look for 200, and it'll tell you what day X that you need to declare this an emergency. You can handle question B and question D on your own using a Desmos calculator and come up with the answer. Let's go to exercise number 3. Talk about quadratic modeling. The cost per widget produced by a factory generally drops as more is produced, but then starts to rise again due to overtime costs and wear on the equipment. Quality control engineers record data on the cost of per widget compared to the number of widgets produced. Their data is shown below. Why should a quadratic model be considered for the data set as opposed to a linear or exponential? Well, I want you to look at your y values. Your x values go up continuously. There's no change in that x, that they're always increasing. But I want you to look right here. I want you to see what's happening. We're going down, we're going down, we're going down. And all of a sudden, right at this point right here, we jump back up. And that's what tells me why we should be using a quadratic. A linear does not go down, go down, go down, and then go back up. An exponential doesn't go down, go down, go down, and go back up. So that's why quadratic is the best model. All right, and to word that is to say it exactly how I did. Because my values in my y column were going down, or my y row were going down, and they were decreasing, and then all of a sudden, once they hit this red line right here, they jumped up and they started to increase. It says, okay, use your calculator to create a scatter plot of this data to verify the quadratic nature. Very simple. First of all, put in your x and put in your y. So let's take a look. The first thing, don't forget, is we're going to type in make sure we identify my x and my y. We have my two sets of data. Then what we're going to do is once we have that in there, we are going to hit Control Dock. Control, and I'll write that down for you. And this should not be new for anybody, but we're going to hit Control Dock, and it's going to say this. And we want to choose the Add Data and Statistics button. Once we choose that, slide number 3 is going to pop up. If you notice, I have my 5 dots out there. 1, 2, 3, 4, 5, 6. I'm sorry, my 6 dots. I have my data. But they're all over the place. What we have to do is we have to click on that to add my variable. And obviously, that's going to be my x. And that'll automatically pop up. You just have to choose x. And you have to insert your y, which will automatically pop up. You just have to choose your y. As soon as you insert that x and as soon as you insert that y, slide number 4 will appear, and it's going to be a scatter plot. The default in your calculator and the only option is to create a scatter plot because we're working with bivariate data, don't forget. So bivariate data, the only type of plot that you can create using bivariate data is my scatter plot. Once you have that scatter plot created, you should recognize that that is a quadratic regression. So that's how, using your new calculator, you can go ahead and create a scatter plot to show you what is the best line, whether it's linear, whether it's exponential, or whether it's quadratic. Thank you, and have a great night.